Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside and bask in the glory of proofs with me today. Oh, people do not like proofs. They do not like proofs because they're new, they're different, they're hard. They don't use numbers as much. It's a lot of letters and even a lot more symbols, and we have to justify things. That's okay. I'm here to teach you it to begin with. And here's the thing, guys. Proofs take a while to learn, so although this 20+ minute video will be used uncovering proofs in that way, I want you to know that there's still a lot more to uncover here. So let this just be the one that exposes you to it. You see me construct a couple, even if you can't do them for yourself, it's a good first step. Now, in order to get proofs covered, we're going to have to know a couple of these things to start off with. First of all, CPCFC, and then a couple other properties of congruence, just to validate some of the reasons that we've had already. And you're going to have to know some of the other math stuff that you've known. You're going to have to know a little bit about midpoints and bisectors and perpendicular and parallel lines, and all those things come into play when it comes to proofs. But we'll get into proofs in the latter half of the video. Let's start with CPCFC. Now, CPCFC stands for corresponding parts of congruent figures are congruent. It's a sentence, which means something. And let's start with the congruent figures aspect. Well, a figure is like a triangle or a quadrilateral or a pentagon or a circle or whatever, right? Those are figures, those are drawings. Here's a figure. Here's a figure. Now, if you were told that your figures were congruent to each other, that means that they are equal in size and shape in every which way, that you can match up parts of one figure to another, but you gotta first identify which parts correspond. And that's the idea here. If you find the parts that correspond in your congruent figures, those corresponding parts will be congruent. So how do you figure out which ones correspond? Well, unfortunately, if you have someone like me teaching you, I might give you very unfortunate looking drawings of me telling you, hey guys, these two triangles are congruent. Can you tell they're congruent? No, you can't tell they're congruent. They don't look congruent at all. But if you have something like this, which is called a congruence statement, then you have actual validation that your two triangles are congruent here. Triangle ABC is congruent to triangle DEF. Whether or not my artistry indicates it, the statement does. The statement does. Now, a congruent statement will establish which parts correspond based on the order the letters are written. A is the first letter of this triangle and D is the first letter of this triangle. That means A and D correspond with each other. And when they do, those parts will also be congruent, such as their angles. Angle A is congruent to angle D because, once again, they are the first letters here. Now, I know they don't look congruent. This was by my intent to say don't go based off the drawing, but make what you will of the drawing that you have. So angle A being congruent to angle D is because they're both the first letters written in the triangle congruent statement. B and E are the second letters, therefore they will be congruent to each other here. I'm going to do a double arc mark to indicate that A is not congruent to B necessarily, but, B is congruent to E. And then C and F are the third letters here. C, F, also congruent. Now, we said parts are congruent, corresponding parts. Angles are not the only parts. In triangles, there are also segments. And segments use two letters to indicate because it's between your 2 points right here. So segment AB, for example, it's congruent to segment DE because A and B are the first two letters of this triangle, and D and E are the first two letters of this triangle. So notice how I keep talking about the letters and what order they're written in. This triangle congruent statement is everything you need to look at to indicate this stuff. You don't even need a drawing for the things that I'm making, but the order completely matters. It is critical to knowing which parts correspond, and then therefore which parts are congruent. BC are the second and third letters, EF are the second and third letters, so those are congruent to each other, and then the same will be for AC and DF. So you'll see me mark some things up. I won't always do them completely like this. It depends on what we're doing based on the proofs. But CPCFC, that abbreviation means something, and we're going to be obviously applying that going forward. Okay, so that's what CPCFC stands for. Now we're going to go ahead and look at a couple other properties of congruence. I'll kind of just give you a minimalistic view of them. Especially, I think we're really only in my proofs here today. We're really only going to look at the transitive property, but that's okay. In later proofs, we'll look at the reflexive property. Honestly, I don't know if we're going to look much at the symmetric property with proofs, but it doesn't mean that it's not something that you would still need to know. Okay, The reflexive property of congruence. Now, here's a statement for it that says segment AB is congruent to segment AB. To you, it's a way of saying, I guess, that a segment is congruent to itself when you're looking at it. And you'd be right. It is stating that a segment is congruent to itself. And you're like, well, no, duh. Why would I ever have to talk about the reflexive property of congruence? I know a segment's congruent to itself. Well, here's where you're actually going to be using it. Let's say that I had some sort of triangle right here, and because I want to use the AB thing, let's call this triangle ABC. Now let's say there was another triangle that was right next to it here, literally joined at the hip, and it was called triangle ABD. So if you saw these two triangles split apart here, there would be a triangle here that's ABC, and a triangle here that's ABD. But the original drawing, once again, was this set. Okay. Now, looking at these two when they're separate, even though they have the letters A and B here, there is no way of knowing for sure that this segment AB is congruent to this segment AB because they're separate and there's no information. We don't have a triangle congruence statement that says anything like it. But if you have a drawing where they're joined at the hip where AB is literally a shared side, in both of these triangles, there's no way that it can't be congruent in both triangles because it's the same segment in both triangles. When it's joined at the hip, it's congruent to itself, but it's really a way of us saying the AB in this triangle is congruent to the AB in this triangle. But that wouldn't be possible without seeing that it is a shared side in both of these triangles here. And that's what the reflexive property is all about, guys. Being a shared side, or in some cases, shared angles. I don't know if you saw this little footnote right here. Everything here also applies to angles. We'll talk about a shared angle, and since this is not one of them, there is no shared angle in these two triangles, but here's a shared side, which states that in the two separate triangles, AB is congruent. And that's what the reflexive property is all about. Like I said, we will not be using it for our proofs in these examples here today, but it will be used in future proofs. Now, it's not the same as reflect. It has nothing to do with reflecting. There's one version of it, the one that you just saw, where you could make one argument that maybe that's what it has to do with, but it's not. Reflex is not the same word as reflect. Anyway, the symmetric property of congruence, it's a way of just stating, it says if AB is congruent to CD, then CD is congruent to AB. You can make a congruent statement either which way, and it doesn't affect the outcome of what you're talking about. This is also true of equations. You probably have seen me do this before. If I have some sort of equation that I'm writing, and I got 6 equals 2x, you might see me say divide both sides by 2, and you get x equals 3. Well, you might ask yourself, Mr. Robinson, how did the 2x turn into an x, and how did it go to the other side? Well, I divided both sides by 2 to get x there and 3 here, and then I switched them. 3 equals x also means x equals 3. I'm writing the variable on the left side, and I'm skipping a step, I'm sorry. But this is called the symmetric property of equality, that you can flip these and it doesn't affect your outcome. So, symmetric property also used, but like I said, it's not really something I'm going to be using in my proofs, at least not as a validating reason for something. So I'm just going to move on to the transitive property of congruence, and you will see this at least a couple of times in our proofs here today. The transitive property of congruence works in transition from one statement to another to lead to your final statement as such. Take a look at this. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. AB finds out it's twinning with CD. CD finds out it's twinning with EF. I guess that means that AB, therefore, is twinning with EF, right? I guess they're triplets together. You know what I mean? So that transition from AB to CD to EF, it kind of jumped, it kind of said, hey, AB and EF, they're brothers as well, right? They also connect in the same way because they have this mutual connection with CD that they're both equal to. If they're both congruent to CD, then they're both congruent to each other. That's what that says. That's what that means there. So this also applies to angles, guys. If angle A was congruent to angle B, and if angle B was congruent to angle C, then apparently angle A is congruent to angle C. And like I said, you'll be seeing these in proofs. So those are 3 other properties that we might be able to use for reasons. Like I said, transitive property will absolutely be used today. And those are just parts of what you're going to be doing for some of the stuff. So now let's get to the proofs aspects. What are proofs? Proofs are an organized way of arriving at a mathematical conclusion founded upon evidence. That evidence might be in the form of definitions, properties, and theorems, and maybe some other things, postulates and axioms and blah, 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 blah. Now, all those different bits of evidence and those reasons and such, if you're new to proofs, you're probably going to have to get a nice big list of them because you won't really know what to say as reasons. Hopefully, you can have a logical conclusion as to why you built your statement in the first place, but you're just not really good at giving that reason. We'll help you with that. It's going to take time, but we'll help you with that over time. Maybe not today, but you'll see some examples of it today. Okay. This is kind of like being in court. It's kind of like being in court and you're trying to convict somebody of a crime. Let's say it's murder. You can't just say, he killed her. You have to have, the DNA and the blood and the weapon and maybe the confession and the video evidence and witnesses and blah, 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 and motive. There are going to be things that you're going to build up a case for, and then you're going to arrive at your conclusion. So every statement in a proof has a reason behind it, even if it is given. Now, given statements, we'll talk about, they're going to be pretty plainly obvious, but basically you couldn't prove something without being given anything, right? If I just said, prove to me that he killed her, well, you're like, well, you have to give me something. Give me something to go off of, right? I need to investigate this. I can't just say he killed her. Most statements are built off the statements before them. So here's the thing. You're going to build a statement, probably a given statement to begin with. And then after that, you're going to build another statement that's likely a result of whatever was given. And then this statement might be a result of either what was given or the statement before that, right? They're not going to be created just out of thin air unless they lead to your conclusion. But most statements are built off the statements before them or what they lead to. And then the proving statement will be the final statement that'll finish off the proof. So after you say, he killed her for this reason, then you're kind of done with your stuff. Okay, so given statements will lead off a proof. You're going to start with given statements, and then you'll have proving statements in the end. So here's an example of a 2-column proof template, just this blank right here. And let's see one that's filled out. Let's see what they stated, and then we'll create some for our own. So this first proof example, you're given a drawing, and you're also given this statement that triangle ABD is congruent to triangle ACD. Now, right off the bat, I'm pretty inclined to write this 1, 2, 3, 1, 2, 3, so you know which parts correspond. In triangle ABD, the A is the first letter, and in triangle ACD, the A is the first letter, so you know that the angle A in triangle ABD is, for example, congruent to the angle A in triangle ACD. Things like that. Will we use those? Maybe not for this one. Our proof is that, what we want to prove, is that point D is the midpoint of BC. We need to somehow build a case that states that in this segment, BC right here, D is right in the middle. One way that I like to build proofs, and I know we're going to look at this one here, but I want to help you understand how they decided to build it. One way I like to build proofs is think of it kind of like a maze. And I don't know if you guys ever do this with mazes, like when you're in a restaurant and you're doing the one, or in the New York Times or whatever. But in a maze, sometimes if you're confused where to go from, when you start from the beginning, and you're like, which way do I go? Sometimes you look at the end. You take a peek at the end and say, well, where do I need to get to? And, you kind of work backwards a little bit and say, okay, I need to get to here. So let me find a way to get to that part. Okay, work backwards to that. And that's what we're going to do here as well a little bit. If we're trying to prove that D is the midpoint of BC, we need to somehow show that it's in the middle of it, meaning that it divided this, that these are two equal parts right here. And that's what they're going to do. Notice that the first statement is the given, that these two triangles are congruent, but the second statement says that segment BD is congruent to segment CD. They say, hey, these two things are congruent to each other. Now, we want to be able to build that case and say that that's true, because if this is true, that would mean that D is the midpoint, but are we allowed to just say that this is true? We're not allowed to just say that out of thin air, but do we have enough evidence to lay this claim down? And the answer is yes. We can say that segment BD is congruent to segment CD because BD and CD correspond in these two triangles. Notice how BD is letters 2 and 3, and CD is letters 2 and 3. These parts correspond. These triangles are congruent by CPCFC. They wrote it right here. But by CPCFC, segment BD is indeed congruent to segment CD. So again, we could not have made this statement if we didn't know that this was true here. So this led to this. You don't have to draw this arrow. I'm just trying to show you that this led to this right here. Oh, and because these two things are congruent right here, and you know what? It really helps to work with the drawing. Put tick marks based on what you start to build a case for. Yeah, hey, guys, you know what a midpoint does? It divides a segment into two congruent parts. And you know what? If you had two congruent segments made from a whole segment right there, that means that middle point is indeed the midpoint. D is indeed the midpoint of segment BC because the definition of midpoint. If I didn't have statement 2, I couldn't make statement 3. I do have statement 2, therefore I can make statement 3. So these kinds of reasons, guys, obviously the given will be a pretty decent reason for you to be able to know. CPCFC hopefully will come into form and you'll understand and learn when it is that you put this. I'm sure this last one you wouldn't have known what to put, but if I gave you a multiple choice option, a list, a pool of different reasons to provide, definition of midpoint really seems to hold true that by definition, by the midpoint's definition, this has to be the midpoint. This couldn't not be the midpoint and have these parts congruent. That kind of makes sense. Anyway, you know, by CPCFC, I could have said, hey, these two are congruent. This is congruent to itself. These are congruent here. These angles are congruent right here. These are... I could have built all this, but I don't need all of that. It's like going through a maze and saying, I could have gone left, and I could have gone right, and I could have gone straight, and I could have done a U-turn. You really just need to find the one that builds you to the end. And the only one that builds us to the end is this definition of midpoint guy that's right there, right? I need to just BD, and CD. Anyway, that one's pre-built. That's an example of a proof. I know it's kind of a lot. Let's do 3 more. 3 more. And like I said, it's going to take up a little bit of time, but let's see. All right, this one is mostly pre-built for the statements, and then we're going to try and find the reasons that justify what it is we're trying to do. Okay, we are given that these two quadrilaterals are congruent to each other, JKLM with NPQR. We are also given that angles J and K are congruent to each other. With this one straight up, guys, I'm just going to go ahead and mark those off the bat. I'm not going to do the full markings of the others for the very reason that, once again, I'm only going to use what I have to in order to arrive at my concluding statement, which is we need to prove that angle J is congruent to angle P. At some point, guys, we're going to have to state that this thing and this thing are congruent to each other. You can't just make the statement. There's not enough information that gives us that. Here's the thing. J and P don't correspond with each other. J's the first letter, P's the second letter in these congruent statements. So we can't just lay claim to that. We're going to have to use what's given, though. Somehow we're going to use this alongside probably this right here to state that those are indeed congruent. So let's start here. Let's write out the givens. Boom, boom. These two are given, guys. It is given that these two quadrilaterals are congruent. It is given that those two angles are congruent. They wrote them in separate steps and separate statements. Sometimes you'll see them write them in the same statement in one step. That's okay. Okay, now notice that they made another statement that says angle K is congruent to angle P. Now that's not untrue. K and P are both the second letters in these quadrilaterals. So, and you know, corresponding parts of congruent figures are congruent. So angle K, we do have a single arc marked for that, is indeed congruent to angle P right there. We can say they are by CPCFC. They're congruent figures. These are corresponding parts, so they're congruent. Now, why did they decide to say that? Because they need to find a way, right? This is the working backwards in the maze thing. They need to find a way to lead J to P. We have information about J here that's going to be useful. We don't really have information about P yet. So what we want to do is work our way backwards and say, what does P relate to that we can connect with J to make this happen? And here's the thing. P is the second letter in this statement, and K was the second letter. Hey, we've used K before. It's right here. So K is one of those, you know, mutual connections with J and P. J is like, hey, I know K. And P is like, hey, I know K. You know, so they're both saying, hey, we both know K. And you know what? That helps lead to state that J is congruent to P. Because J is congruent to K, angle-wise, and because angle K is congruent to angle P, that makes angle J congruent to angle P. Why? This is known, as you saw before, guys, as the transitive property of congruence. And that's where we are using that reason right there. And you know what? If you look at the drawing, you can also see the connection. We made J congruent to K based on what was given. We knew that K and P corresponded, so they were congruent. Notice how they all have single arc marks. J and P also do as well. Because J is congruent to K and K is congruent to P, J is congruent to P. That is the transitive property of congruence at play there. And there's a proof built out. We built out the reasons. Honestly, the statements are actually harder to build. The reasons, maybe you don't know what they are, so if you have a list of them, I think you could probably come up with some of them. The statements are probably harder to build because you got to actually build the case for yourself. You got to know what you're going to connect. All right, 2 more, guys, and they're going to be done completely from scratch, meaning I'm even going to make the 2-column part with the statements and reasons. They have the drawing, they have what's given, they tell us what to prove. They'll always tell you what to prove, and we kind of, there's only really one way to prove it. If that, like, they wouldn't give us this if we couldn't prove it, basically, right? So we got to know that this is going to be a true thing, but how do we get there? It's kind of like, we know he killed her, right? But it's not what you know, it's what you can prove. All right, guys, triangle SVT is congruent to triangle SWT. Obviously, we're going to have to work somewhere with corresponding parts of these 2 congruent figures, these triangles here, to work this thing out. Otherwise, they wouldn't give us the statement in the first place. By the way, sorry if I have any hitches in my video. I don't see any right now, but I'm getting a sign in my thing that says encoding overloaded. So apologies if there are hitches in this thing. There's nothing I can do right now with it. Okay, so our first statement we're going to make, guys, is our given statement, that this triangle is congruent indeed to this triangle right here. That is given. Now, we need to eventually lead to the fact that this segment bisects this angle right here. ST bisects angle VSW. Here's angle VSW. And what is an angle bisector? An angle bisector is a segment that divides the angle into 2 congruent parts. Now, we don't know that this thing bisects this. We need to prove that this is bisecting it, though. So in order for us to do that, guys, I think we need to figure out that these 2 angles are congruent to each other. We need to somehow show that this angle here is congruent to this angle here. And then if they are, just like the midpoint one, and then if they are congruent, then that must mean that this is a bisector. So can we lay claim and say that this angle VST is congruent to this angle WST? Well, in order for that to be true, that would mean that the S in this triangle would have to be congruent to the S in this triangle. And that could be the case if in this triangle congruent statement, if S is in the same placement in both the triangles. S is the first letter in this triangle, S is the first letter in this triangle. Hey, the S's correspond. That means the angle S in this triangle is congruent to the angle S in this triangle. Now, the way that I want to write that out, I can't just say angle S is congruent to angle S because they are 2 specifically different angles. This is angle, we can call this, say, VST. Angle VST is congruent to angle, say, WST right here. WST. Because CPCFC, once again, these were corresponding parts. The angle S's, because they were the first letters here, they're congruent to each other. All right, well, guys, that leads us to our concluding statement here that allows us to say that the segment ST bisects angle VSW for the same reason that the midpoint thing did, guys. It's its definition. That's what the definition of an angle bisector is. If an angle bisector indeed divides an angle into 2 congruent parts, then an angle that is divided into 2 congruent parts must mean that that segment is an angle bisector. And that's what that thing's saying there. It's okay if you're overwhelmed by this. I do want you to hear the things and see, I want you to take note and see how things are leading in, though. That doesn't mean you can create them for yourself yet. But, just we're taking everything in stride right now. I got one more. We're also going to do it from scratch here. Last one. Statements and reasons here. This time they are quadrilaterals that are congruent to one another, and once again they have corresponding parts. I like this time that they do have them facing the same direction here, or so it seems, as we saw in my own drawing. You can't always trust it, but let's go ahead and see what corresponds. We call this ABCD, ABCD, congruent to EFGH, EFGH. Yeah, these are both oriented the same way. Corresponding parts all do align. So top left is congruent to top left, right side is congruent to right side, things like that. Awesome. Okay, and they also tell us that these 2 segments here are congruent. Segment AD is congruent to segment CD. I'm going to mark that one up immediately just so we have something kind of in fruition, single tick marks. But let's start writing some of that stuff out, guys. Quadrilateral ABCD is congruent to quadrilateral EFGH. And this thing keeps telling me my encoding's overloaded, so if this keeps hitching and pausing, I really apologize. This actually, guys, you don't know this right now. This is actually the second time I'm recording this video. The first time I recorded it, my microphone apparently was off. Who knew that a microphone that's plugged in also decides to not be working? So apologies for that, because the other one was actually smooth. All right, so that's given. You know what else was given was segment AD was congruent to segment CD. By the way, no apologies if this thing is running smoothly. I'm glad if it is. All right, those are our givens. Let's kind of figure out how we are going to get to the end of the maze. Okay, because this time we got to build the statements for ourselves. We got to somehow connect AD with GH. Whoa, GH. We haven't heard about GH before. We heard about AD. We even heard about CD. What's this GH nonsense here? Where is GH? Well, GH is right here. Somehow I need to show that this is congruent to that, right? I need to make that connection. Well, here's the thing. GH is on the bottom, and I did say the bottom they'll correspond. GH corresponds with CD. GH is the third and fourth letter. CD is the third and fourth letter. Maybe we can make a statement that says CD is congruent to GH because of CPCFC, right? These are congruent quadrilaterals. So if we said CD is congruent, segment CD is congruent to segment GH by CPCFC, then we do seem to have that transitive property in play here. If AD is congruent to CD and CD is congruent to GH, then AD is congruent to GH by the transitive property of congruence. And that's what we have here. AD is congruent to GH by the transitive property of congruence. And that's it. That's a proof, guys. These proofs, they hardly ever use numbers. I don't remember using any numbers here. They hardly ever use numbers, but they are a case that says it is indisputable evidence that these things happen. There is no talking around it at all. Excuse me. The reasons are substantiated based on it. We built up a case, and it led us to that conclusion. And actually, just to help you out conclusion-wise, right, these two things were given right here. Because of this statement, I was able to make this one. And because of these two statements here, I was able to make the final one, right? Because of this and this, I could lead to that final thing. You don't have to draw those arrows one more time, but that's just kind of something that might help. All right, guys, so that is it for this one here. And actually, let me kind of show you the check mark thing. We did all of these here. Awesome. That is it for this one here, guys. I know, once again, that can be a little, just I hope you bared with me. I hope you got the exposure, and through more videos and through more practice, you'll start to get it. I promise you. Okay, that'll be it for this one, guys. Thank you. Take care.